Derivatives of trig functions, Part 3. We're about to review the derivatives of trigonometric functions, but first let's review some information we'll need. We'll need the limit definition of a derivative, so f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. We'll need these useful trig identities, particularly the sum of different angles, so sine of x plus y and cosine of x plus y. And we'll need these trigonometric limits that you'd want to memorize. Let's start with the derivative with respect to x of sine of x. So we'll need the definition of a derivative to help us with this. We have the limit as h approaches 0 of f of x plus h, so that'll be sine of x plus h, minus f of x, so that's sine of x, all over h. And one of the first things we're going to do is we have sine of x plus h. So we're going to use one of our angle identities to rewrite this so that we don't have the sum of some angles in our limit anymore. So this will be equal to the limit as h approaches 0 of sine of x plus h will be equal to sine of the first angle x times cosine of the second angle h plus sine of the second angle h times cosine of the first angle x. So that's just rewriting our sine of x plus h using one of our identities. Then we still have our minus sine of x. And we are all over h. So there's going to be a couple things guiding our next decisions. The first thing is that we have the limit as h approaches 0. So the sine of x's and cosine of x's aren't going to be impacted by this limit. So we can kind of separate them off. So let's group things with sine of x together and group terms with cosine of x together separately. Keeping in mind that this cosine of h is going to follow this sine of x along, and this sine of h is going to follow this cosine of x along. And if we look at this, we can actually look at this division by h separately for each term. So this will be equal to the limit as h approaches 0 of, let's group our sine of x terms together. So we have sine of x, cosine of h, minus sine of x, all over h, because we have that common denominator of h. And we're adding the limit as h approaches 0 of our sine of h, cosine of x, all over h. So we took our terms with our sine of x's, and we took our term with our cosine of x. And now, because the sine of x and cosine of x will not be impacted as the limit of h approaches 0, so limit as h approaches 0, we can factor those out because they're just not impacted by that h. So we'll factor out our sine of x, and that'll be times the limit as h approaches 0 of cosine of h minus 1 over h, plus we'll factor out that cosine of x, which isn't impacted by the limit as h approaches 0, times the limit as h approaches 0 of sine of h over h. And now some of these limits look a bit familiar. So we have sine of x times, well, the limit as h approaches 0 of cosine of h minus 1 over h is equal to 1. Sorry, I lost my x. Plus, sorry, is equal to 0. I don't know why I said 1. I was already thinking to the next part. Plus cosine of x times the limit as h approaches 0 of sine of h over h is equal to 1. So we have sine of x times 0 plus cosine of x times 1, which leaves us with just cosine of x. So the derivative with respect to x of sine of x is equal to cosine of x. Let's find the derivative with respect to x of cosine of x. We'll start by using the definition of a derivative. So this would be equal to the limit as h approaches 0 of f of x plus h, so cosine of x plus h, minus f of x, so minus cosine of x, all over h. And then to try to simplify this, we will need to use one of our identities in order to rewrite that cosine of x plus h. So this is equal to the limit as h approaches 0 of, well, cosine of x plus h will be equal to cosine of x, cosine of h, minus sine of x, sine of h. So that's just using one of our identities to rewrite the cosine of x plus h. Then we still have our minus cosine of x. And this is all over h, which is the same thing as dividing each of these terms by h. Now, since we have the limit as h approaches 0, we want to take all of our pieces that will not be affected by that limit. So anything where we just have an x, so the cosine of x's, and our sine of x, because those won't be impacted as h approaches something. And we'll group our cosine of x's together and group our terms with the sine of x's together, keeping in mind that the cosine of h will follow that cosine of x, and the sine of h will follow that sine of x. So this is equal to the limit as h approaches 0 of, let's first look at our cosines. So we have the cosine of x times the cosine of h minus the cosine of x over h, because they have that common denominator. So that's our cosine of x's, minus the limit as h approaches 0 of sine of x, sine of h over h. So that's my term that had this sine of x. And now, because the cosine of x's and sine of x's will not be impacted by that limit, we can factor them out. So we have the limit as h approaches 0 of, oh sorry, I actually wanted to pull it out, so cosine of x, just factoring it out, times the limit as h approaches 0. And I can just pull that out without having to worry about a limit, because h approaching 0, again, does not impact my x. And then I'm left with cosine of h minus 1 over h minus sine of x times the limit as h approaches 0 of sine of h over h. And then evaluating these limits, we have the cosine of x times this limit is one of our known limits and evaluates to 0, minus sine of x times this is another known limit, and this one evaluates to 1. So cosine of x times 0 is equal to 0. So we're left with negative sine of x is equal to the derivative with respect to x of cosine of x. We can now use the derivatives of sine of x and cosine of x to figure out the derivatives of the remaining trig functions without having to use the definition of a derivative. So first we'll rewrite whatever trig function, in this case tangent x, in terms of sine and cosine. So this will be equal to the derivative with respect to x of tangent x is equal to sine of x over cosine of x, which is a quotient. So we can use quotient rule on this, where in the numerator we have this sine of x, and in the denominator we have this cosine of x. So this will be equal to low, which is our cosine of x, d high, so the derivative of sine of x, which is cosine of x, minus high, so that's sine of x, d low, the derivative of cosine of x is negative sine of x, all over low, so all over cosine of x squared, which gives us cosine squared x minus, or rather plus, sine squared x all over cosine squared x. You should know that cosine squared x plus sine squared x is one of our Pythagorean identities, and this one you should definitely know. So we have 1 over cosine squared x, which is equal to secant squared x. So the derivative of tangent x is secant squared x. You'll want to be able to find the derivatives of trigonometric functions. However, you won't want to use the definition every single time that you need to find the derivative of a trig function. So you'll want to make sure that you have these 6 derivatives memorized.